Ladies and gentlemen, in this video, we're talking about how to convert from standard form to scientific notation, and then also scientific notation back to standard form. The only thing that we're not going to look into is rounding to significant figures. The only thing that I want you to get out of this video is how to go from one form to the other without any issues. So let's go ahead and get into the video.
I guess I should know what the softest every phase the words remain as shown in the summer snow. Well, it hasn't been the easiest years in a life.
Now, the reason you learn about converting standard form to scientific notation is sometimes you're working with numbers that are incredibly small or incredibly large. So instead, we like to convert those to scientific notation to look at them easier. So let's go ahead and start with 5 problems on standard form to scientific notation, and then we'll look at another 5 problems that are the reverse, scientific notation back to standard form. So if we take a look at number 1, our goal here is to make a number that is going to be greater than or equal to 1, but less than 10. So that's my first step that I have in green there. So let's go ahead and move the decimal point to the right. That way we can get a number that is greater than or equal to 1, but less than 10. So I'm going to move it once to the right, twice, 3 times, and then on the 4th move, it's going to be between that 2 and 1. So we're going to end up getting 2 and 1800ths. Well, 2 and 1800ths definitely is greater than or equal to 1, but less than 10. So it falls in that range that we need. But then we need to make sure that we raise it to a power of 10. And the reason that we're raising it to a power of 10 is because every time you move a place value, well, that's going to be a power of 10. So we moved it 4 times to the right. Now, the only issue is it going to be a positive 4 or is it going to be a negative 4? And the easiest way to do this is that if you were looking at a number or starting with a number that is less than 1, your power is going to be negative. So in this case, this decimal is way smaller than 1. So this is going to be 10 to the, not the positive 4, but negative 4 because our original value was smaller than 1. And this is our final answer in scientific notation. Now let's go ahead and take a look at number 2. So we have 782 billion, and we need to make a number out of this that is greater than or equal to 1, but less than 10. But this time around, I don't even see a decimal point. If you don't see a decimal point, it's always at the end of the number. So now that we know that information, let's go ahead and get a number that's between 1 and 10, or greater than or equal to 1, but less than 10. So we're going to move it once to the left this time, twice, 3 times, 4, 5, 6, 7, 8, 9, 10, 11, and we finally end up getting a value that is in our range. So we have 7.8253, and we're going to raise it to a power of 10, and we move this 11 times to the left, and our number this time around is larger than 1, meaning that our power is going to be a positive 11 instead of a negative 11. So if you move it to the right and the number's less than 1, it's definitely going to be a negative power. For number 2, we moved it to the left. Our number's larger than 1, so our power is going to be positive. Now let's go ahead and take a look at number 3. So we have a decimal point, our number's less than 1, and we are moving it to the right, so I know my power at the very end has to be negative. So we're going to move it once to the right, twice, 3 times, 4 times, 5 times, and then it looks like a 6th time until we get that range. 7.2 or 7 2/10 times 10 to the negative 6. Again, moving to the right, numbers less than 1, power or exponent's going to be negative in this case. Now let's jump down to number 4. Again, I don't see a decimal point, so it's going to be at the end of the number. And we need to move this to the left. We have a number that's larger than 1. So we're going to move it 1 place value, 2, 3, 4, 5. Now we can't stop here because it's at 10, but it can't equal 10. It has to be less than 10. So we have to move it one more time to satisfy the scientific notation requirements. So this is going to be 1, because again, it can be greater than or equal to 1. So 1 times 10 to the 6th. And again, it's going to be positive. We move to the left, and our number's larger than 1. Now let's go ahead and take a look at the next one before we move on to scientific notation back to standard form. So again, we have a number that is less than 1. We are moving to the right here. So we have 1 place value, 2, 3, 4, 5, 6, 7, 8, 9. We meet that range, so that's going to be 8 and 4/10 times 10 to the, not the positive 9, but the negative 9. Again, moving to the right, numbers less than 1. Now let's go ahead and take a look at the reverse. Scientific notation, back to standard form. Now we're looking at the reverse. We're going to go from scientific notation back to standard form. So let's go ahead and take a look at the first one. We have 3 and 87/100 times 10 to the 5th. And what we do for scientific notation back to standard form is it all has to do with our exponent. If the exponent is positive, in this case, number one, our exponent's 5 and it's positive, we're going to move our decimal point 5 place values to the right. Now, if it's negative, we're going to move that many place values to the left. So let's go ahead and do number one first. So we have 3 and 87/100. And we need to move our decimal point 5 places to the right. So we're going to move it once to the right, twice to the right, but then we're out of numbers, but we still need to move it 3 more place values. So all we have to do is add in extra zeros at the end of our number. So we have 1, 2, 3 more jumps, and then all I'm going to do is tack on 3 more zeros to fill in those empty spaces. So the correct answer in standard form is going to be 387,000 for the first one. Now let's go ahead and make our way over to number 2. We have 9 and 6/10 times 10 to the negative 8th. So because it's a negative exponent, we are going to move 8 place values to the left. So let's go ahead and do that. So we have 9 and 6/10. We're going to move it once to the left, but then we need to move it 7 more times, even though there's no zeros here. So twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, and our decimal point will end up here. And then we just tack on all of those zeros for the other place values. Now we can go ahead and rewrite this. So we have 0.00000096. Now, the reason that this becomes an issue with students is you might simply miscount the number of place values you've moved. So they might drop a 0 on accident, add an extra 0. And I think that's kind of where the issue lies with a lot of students when it comes to just moving too quick. So take your time on it. Don't rush through this because it's not that challenging of a topic. But it is challenging if you rush, you think you did it all right, and then all of a sudden you get like a C on something when you should have got an easy A. So let's go ahead and take a look at number 3. We have a negative exponent again, but I don't see a decimal this time. So remember, the decimal point is behind the number if you don't see it. It's negative, so we're going to move it to the left 4. So there's 1, 2, 3, 4. Decimal point's going to be here, and then we tack on 3 zeros for the 3 place values we still needed to do. So we get 0.0005 for our final answer in standard form. Now let's go ahead and take a look at number 4. We have 6 and 345 thousandths times 10 to the 7th. This is a positive exponent, which means we're moving to the right 7. So let's move it once to the right, twice, 3 times, and it looks like we have to move it 4 more. So 1, 2, 3, 4. Add our 4 zeros in there, and our final answer for this is going to be 63,450,000 for number 4. Now let's go ahead and take a look at our last one before there's 5 problems I want you to try out on your own in the practice session, which is going to be a mixture of standard form to scientific notation and then vice versa as well. So we have a negative power, meaning we're moving to the left here. So 2 and 56/100, we need to move it once to the left, twice, 3 times. Decimal point's going to be here. We throw in those 2 zeros, and our final answer is going to be 0.00256 for number 5. Now let's go ahead and make our way over to the practice session. It's time for the practice session. Do you have what it takes to go 5 for 5, going from scientific notation to standard form or standard form to scientific notation? So I encourage you to pause the video here, try out all 5 of these questions on your own just on a scratch piece of paper, and when you think you have all the correct answers and everything's converted to the form that you want, play the video and see how you did. So I'm assuming at this point you've tried out all 5 of these and you're ready to go over the correct final answers. So let's go ahead and take a look at the first one. We have something written in scientific notation already, 6 and 22 hundredths times 10 to the 8th. I see that the power is positive, which means we should be moving the decimal point 8 place values to the right. So we have 6 and 22 hundredths. Let's go ahead and move 8 to the right here. So 1, 2, and then we're out of numbers, which means we're going to have to move the place value 6 more times. So 1, 2, 3, 4, 5, 6. And then we have 6 filler zeros here. And our final answer is going to be 622 million for the first one. Now let's go ahead and take a look at number 2. This time around we're in standard form and we need to get it to scientific notation. We have a number that's smaller than 1, which means my final answer, that exponent, should be negative. Now let's go ahead and get a number that's between greater than or equal to 1 or less than 10. So we're going to move it once to the right, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, and we're going to get 7 and 42 hundredths times 10 to the negative 8th for number 2. Now for number 3, we have a positive power again, so we need to move our decimal point to the right for standard form, and our decimals after the 8 because we don't see it. So let's move it once, twice, 3 times, 4 times, 5 times. So we're adding in 5 zeros here. And our final answer is going to be 800,000 for number 3. If you are 3 for 3 right now, very, very nice job. Headed into the final 2. So we have 7 million in standard form. Let's go ahead and make it into scientific notation. Our decimal point is at the end of the number if we don't see it. Our number is larger than 1. We're going to be moving our decimal point to the left, meaning our power is going to be positive in this problem. So let's go ahead and get a number that's greater than or equal to 1, but less than 10. So we're moving it once, twice, 3 times, 4, 5, 6. So we're going to end up getting 7 times 10 to the 6th for number 4. And then finally, our very last one in scientific notation, we have a negative power, meaning that we're going to have to move the decimal point to the left 6. So we have 3 and 924 thousandths. We're moving it once, twice, 3 times, 4 times, 5 times, 6 times. Is going to end up here. And then we have 5 zeros to fill in the empty space. So we're going to end up getting 0.00003924 for number 5. Hopefully you went 5 for 5 in the practice problems. If you did, very, very nice job. I hope this video helped you out with converting between standard form and scientific notation, or the reverse, scientific notation to standard form. If it did, leave a like on the video, comment any other topics you want to see in the future, subscribe, turn on that bell for post notifications, and we'll see you in the next one with some more mathematics.
And I don't even care.